Section 4.10 is the quadratic formula. So let's solve quadratic equations. We can factor them. We can use a graph to do it and find some intersections. And now let's use a formula. Interpret the solutions in the context of a problem. Okay, so now we're back in track for figuring out why the heck we do all of these things in math. Let's see, x squared minus 2x plus 1 equals 0. So first, I see that it is set to 0. Check. Okay, because of the 0 factor property. 2, factor. So our job now is to go ahead and figure out, and after that we do the either or thing, use the 0 factor property. So our job is to do step 2 because step 1 has been done for us. So x squared minus 2x plus 1 is equal to this first linear factor times another linear factor. Okay, so what by what equals x squared? X by x. And what by what equals 1? And, okay, a couple different guesses here. I think there's just like 2 guesses I can think of. First, 1 times 1 makes 1. I mean, don't get me wrong, there's other things like a half of 2 is 1. Okay. But when I multiply this out, so when I actually check this, I see that x squared plus 1x plus 1x, and then, so I see this by this is x squared, that by x by 1 is 1x, 1 by x is 1x, and 1 by 1 is 1. But notice this is what? Plus 2 x's, and we need minus. So that's out. Switch and check. So let's see, x by x is x squared. X by negative 1 is 1x, but it's opposite style, so negative 1x. And again, another negative 1x. And negative 1 by negative 1 is positive 1. That works. So, yay. Okay, we have factored it. So now, factor. And then we do our either or. So, because now we have the situation where x squared minus 2x plus 1 is equal to the factor x minus 1 times the factor x minus 1, and that we know is equal to 0, then we can say either x minus 1 equals 0 or x minus 1 equals 0. In this case, x equals 1. In that case, x equals 1. So our solution is then x equals 1. And if we look at this, 1 squared is 1, minus 2 by 1 is minus 2. So 1 minus 2 plus 1, 0. Okay, let's do it again. Okay, step 1. Set equal to 0 in order to use the 0 factor property in step 3. So step 3 has the either or, and that only works, remember, if we set it equal to 0. So I'm going to have to add 21 to both sides. So 2w squared plus 17w plus 21 is equal to nothing. So we needed to add 21 to both sides so that we can set this equal to 0. Step 2. Factor. All right, so let's see. Our job is to rewrite this as 2 linear factors being multiplied. Well, we know that something by something has to equal 2w squared. And that to me is 2w times w, because there's a w by w in here. And then we also know that something times something else is 21, and there's positivity all around. So maybe 3 and 7? 1 and 21, 3 and 7. I'm going to start with my initial guess of 3 and 7. Okay, so here we go. And then I just like to get myself prepared for being wrong. Okay, so my initial guess is that, let's go, positive 3 by positive 7 makes positive 21. And then we check it, right? So what we see is 2w squared, and then 2 w's by 7, that is 14 w's, 3 w's, okay, plus 3 more w's. Oh my gosh, I can't believe it. I think we got it right on the first try. Oh, wow. How lucky is that? Okay, we didn't need this. That one worked out. Yes. So 14 and 3 of them. Happiness. Okay. So now we know that either, okay, so step 3, either or, also known as the zero factor property. We know that either 2w plus 3 has to be 0, or w plus 7 equals 0. Well, if w plus 7 equals 0, that's friendly. W equals negative 7. And if this were the case, that means that 2w has to be negative 3, because negative 3 plus 3 is 0. So, and then it would have to be scaled down. So 2w would have to equal negative 3, but that's 2 of them, so we're going to need half of that. So negative 1.5. I feel like we've actually done that factoring before, or at least seen this problem. Maybe didn't do the factoring, I'm not sure. Nonetheless, I'm going to go back and write these solutions down. So we just found that w is equal to negative 7, or w is equal to negative 1.5. Wow, I just had to barely squeeze that in here. Sorry about that. Okay. Great, so set to 0, factor it, either or. Got it. Set to 0, factor it, either or, solution. Set to 0, factor it, either or, solution. So far, so happy. Okay, and now number 3. Let's do this all over again. Step 1. Set equal to 0. Check. Thank you for doing that. And step 2, factor. Okay, here we go. So we have x squared minus 5x's plus 2 equals 0. And our job is to multiply 2 linear factors in order for this to happen. And again, I'm giving myself a little bit of latitude for screwing up. So, but I do notice that we immediately have something by something to equal x squared. So x by x will give us x squared. And x by x will give us an x squared. Okay. I also see that we have something by something to equal positive 2. So naturally my first guess is to say 1 times 2. 1 times 2 makes 2. And then we check it. Okay, so x by x is x squared. X by 2, that's 2 x's, positive. This is 1x, positive. And positive 1 times positive 2 is positive 2. Okay, so it looks like the x squared is good, and the plus 2 is good, but this would be 3 x's. Bad. Okay, so, and I see that this is going negative, so let's suppose we do, and that's 3. So let's suppose we do negative 2 times negative 1, because that will also multiply to positive 2. Negative 2 times negative 1 is positive 2. So let's try that. X squared, okay, that one, minus 1x minus 2x's plus 2. That's negative 3x's in the middle. So we still haven't gotten 5 of them. I'm really struggling here. So, maybe this is y. Factor? I'm super stuck. I mean, there's no other way I can do x squared. It's x by x. Could do 1 by x squared, but then I wouldn't have what I need in the other terms. And there's no other way to I mean, if I did a half of 4, just out of curiosity, what if I allowed some negative fractions in here? So just to see, right, we would still need x by x, but now we're saying, what if we did half of 4 to get 2? Very interesting idea. Let's see. X squared minus 4x's minus a half x plus 2, because a negative times a negative is a positive and half of 4 is 2. So I still have the x squared, that's good. I still have the plus 2, that's good. And now I have negative 4 and half x's. That is closer. Oh man, I mean, but how many fractions am I going to have to try before I get close enough, right? So this is closer. But then I think to myself, fractions? Like, there are infinitely many of these. Okay, so then in rolls the quadratic formula. So the quadratic formula says if y equals ax squared plus bx plus c, the general form of a quadratic, then the solutions to ax squared plus bx plus c equals 0. So notice we still have to do this set to 0 business because it's based on the 0 factor property. Then the solutions to this are given by x equals the opposite of b plus or minus the square root of b squared minus 4 times a times c, all of which is scaled down by double A. Okay, now I need you to see something right off the bat before I get into the next remarks or whatever. If I cover up this square root thing, there's the formula for the vertex, the opposite of b over double A. That's the vertex. But now if I add these square roots, now I'm in business for these solutions. So, and we have to put this in general form, not in factored form. Got it. Okay. Couple of remarks. First, the plus or the minus. So the plus and minus means do each separately. Okay, one at a time. To get up to 2 solutions. Oopsie. So if you're adding some amount and you're taking away some amount, then you're going to get 2 different values. You know, for instance, if we have 5 and we add 2, we get 7. But if we had 5 and we took away 2, we would get 3. So adding and subtracting means you're going to have do one at a time, but you're going to have two different outcomes, two different values, because adding an amount and subtracting amount, two different things. Okay, another remarkable thing about quadratics is that quadratics equations then they could have two solutions. They could have only one, because what if you're adding and subtracting 0? If you add and subtract nothing, then like 5 add 0, you're 5, and 5 take away 0, you're 5. So that's when this plus or minus wouldn't make a difference. But then there's also a square root in there. So here we go. So quadratic equations. Can have two distinct answers, solutions, one solution, or no solutions. And I'm going to tack this in. It all depends on how much we're adding and subtracting. And that add and subtracting part was adding and subtracting this radical. So based on what happens with the root. Yeah, if that square root turns out to be 0, you have one solution. If that's because you're adding or subtracting nothing. If that square root ends up being like square root of 49 and you're adding and subtracting 7, then you're going to have two different answers. One where it's add 7, one where it's take away 7. But what if that square root, can't even exist on its own? Then you're going to have no solutions. Okay, and one more quick remark is that the struggle that I see most students have is the order of operations. So, or also copying it correctly. So, the order of operations for the quadratic formula goes first, do under the radical. So, 1. Radical's value of b squared, putting parentheses around that b, minus 4ac. So that's the first thing you do, because even though they aren't explicitly put in there, implicitly there are parentheses put around this radicand. So that's the first step in the order of operations. Second, so do the radical's value first. Second, actually take the square root. Okay. Third, add or subtract as two separate problems. And then last, divide. I didn't put this, but you should have doubled the a before you actually do your division. Sorry, that I probably should have added that as a step. But nonetheless, here's the order of operations in terms of the quadratic formula. So because this has square roots in it, let's take a peek at this. Now, this actually came from section 4.2, but I noticed in 4.2, all of those are actually completely doable, but here you get into some fishy business. So let me show you what I mean. The square root of 4 is 2 because 2 squared is equal to 4. So it is the square's root. 2 squared is 4, so the square root of 4 is 2. The square root of 81 is 9 because 9 squared is equal to 1. So it is the root of the square. Square root of 81, 9. What about the square root of 121? I believe that's 11. Because 11 squared is 121. And so 11 is this square's root. And, ooh, square root of 1. Well, the square root of 1, 1, because 1 squared equals 1. I got it. I'm on a roll here. Square root of 0 is 0 because 0 squared is 0 times 0, and that's 0. Uh-oh. I have no idea. Ew. So now I'm going to go to my calculator, and I'm going to say square root of 117. Yep, it's not nice. Is approximately 10.8. Because 10.8 is approximately 117. Okay, so this, I'm looking back at number 3, because 121 is pretty close to 117. It's 4 away. Oh, but that doesn't mean we added 4 or took away 4 from the 11, because then 7 squared, so that didn't work. So we really couldn't do this one, take away that one to get the square root of 117. So I need you to know that. But I also need you to know that a lot of square roots are nice, but more of them have to be approximated. Okay, and then what about this? So what squared would give 25? Well, if I give 5 squared, that's positive. If I give negative 5 squared, negative 5 times negative 5 is positive 25. That's sadness. So, does not exist. Well, it's imaginary actually, but we are doing all of our problems and we're solving them in real. So all of our class's problems, we're only looking for real solutions and not implied, implicit, or imaginary solutions. So, or complex, however you want to say it. So this, we're just not going to do it. Yeah? Okay, so in the next video, what we're going to do is, and this is what I mean by funny business, right? In the order of operations here, if this square root doesn't exist, then there are no real solutions. Okay, I could have put in the word no real solutions and been more accurate. However, so this is the funny business when it comes to that. And a square root being strange is okay, but the square root being 0 is also okay, and that's when there would be one solution. Okay, so in the next example, we are actually going to use the quadratic formula, and then we're going to apply it to a situation.